Yo, welcome back. So this is part 2 of the fuse pull video, but I'm actually at the point now where I'm going to be putting the earth rod in. So I wanted to do a separate video for this, show you the driving in of the earth rod, a bit of the regs about it. I've never actually drove in an earth rod myself before. I've tested many. Sorry, it's just starting to rain. Just pranging about my camera. I've tested many, so I know a bit, but I've never actually driven one in myself and sort of initially verified one, so that should be cool to do together. Got 2 rods. It was a very dry day. Now it's about to get a bit wetter, so that's going to be interesting on the results, and I'll sort of show you the main setup as well, because in the previous video we had a few issues with that. But yeah, let's run the intro and I'll go get the earth rods out of that. Right, I've got my earth rods, both of them. Need to try and get this open. Cheers, bro. Yeah, 2 earth rods, which I'm going to be driving into the ground in this little pit. So I spoke about the setup in the last video, but we'll go over it again. This is the hole that I was in. This is the main setup. So we've got our meter and our mains all sorted out. Meter's live, comes into that isolator, it's dead. Fuse board, 2 socket circuits, and then my earth is just coiled up there. So that's going to be a TT earth. You can see here it says TT me please. Even though there's probably a million earth rods on all the joints around this place, I think partially because it's probably a building site and partially because of the area. I'll try to show a drone shot and show you where we're in, but it's quite a confined area with lots going on. They want a TT earth, so that's what we're going to do today. This duct was actually put in for me. It'd need cutting short, but I'm not going to use it. I'm going to save that for the future supply out, and I'm actually going to send the earth through this duct with the supply, and I'm going to put it in this corner here. We've got 2 rods that we're going to drive in. It does look like it wants to rain, but yeah, it was very dry today, so it was a good day to get, you know, a true reading or the worst case reading, but it does look like it's going to rain. Hopefully it holds off. We're going to go in this corner, and we can actually go anywhere pretty much because this has all been CAT scanned. So these buildings here getting knocked down, like I said in the last video, they're building some houses way up over there, and part of that sort of process meant that this whole area was CAT scanned, and yeah, we know exactly where the gas is and where the lecky is, and yeah, we're safe to go pretty much anywhere here. So I'm going to go in this little corner. We've also got a pit to be fitted, so it's accessible in the future. So I want to leave my rod about 50 mil below proposed ground level, which isn't going to be far off this sort of slab. So I'm going to make sure I do that. We're going to drive the rod in. We're actually going to use my trusty sledgehammer. The builders have got a Kango to sort of do it without so much manual labour, but I have never done an earth rod before. I've tested loads. I know what I'm doing pretty much. We'll run through the regs and stuff like that too. But I've never actually driven one in, so I wanted to just do it the proper way, so I can say that I've done that, I guess, because I'm sad. But yeah, we're going to change lens, maybe get our raincoats on, and we'll get cracking with getting this earth rod in. Right, so these are our lovely copper earth rods. We've got 2 of them, and we've got should have a joining bolt. So one of the ends is actually pointed, so that's going to help us out a little bit. I'm going to put this on because I'm about to smash the hell out of it. Now you don't really want to hit these too much. Like I said, I've never done one before, but common sense says I don't want to whack the hell out of that or the thread. One of the boys said, great shout to Stoey, grab a hole saw, chuck it over there. You probably ruin your hole saw, but you're not going to ruin your earth rod. We're going to go, I mean, what we should do, to be fair, is get this out and see how much we've comfortably got, I suppose. Get some tie-ups. Tie-ups on this. Go, and we've got more than enough to sort of rise up, so I'm going to go warning sign out of the way. Go about here, I think. There we go. That's a good start. hasn't gone very well. Now, I'm so sorry, Jude. I owe you a monster. However, this is really going to help our readings. Think about all the electrolytes in that drink actually running through the soil. There we go. Probably going to get like 0.35 now. Probably going to be better than PME. What I could have done with is another joining cap. Smooth jaw's gonna bite me in the arse now. Yeah, I want to be careful now because I don't want to damage this. I think I might be okay, maybe. Get some height on it. I'm making no progress. What have I hit? I gave it so much lemon. Now I've hit something. I'll probably have to get the Kango out. It's going to do the same thing, isn't it?
Yeah. Obviously. It's a bastard, that thing.
What's the crack with it?
Yeah, it just takes some. Yeah. Is it not working at all?
I've just clicked it on. You said, I know what you mean, it's a bit dodgy, isn't it? I just got it to...
Oh, that should be going then. Is that
the old switch.
That box going?
That done the job, didn't it? Oh, that done the job. Okay. I think we're yeah, we're back on manpower if we want to be. Let's just tie it up. So, I mean, we're well below there. Yeah. What I need is something straight. This is going to be incredibly inaccurate, but I'm just trying to get a sense of where we are with ground level. Yeah, we're well below in all aspects. Yeah, should get a laser out, but that will do. That will do. I mean, I've seen these be used before, but I'm just not convinced that's the right way. This is purely for compression, that's what I think. I think you tighten this bolt up and then it just compresses on. Clamps the earth cable on. It's not designed to be lugged. This isn't a luggable terminal. I mean, I could leave that on there, but then that's just going to be loose. Just ring the TT key. Big thumbs. Was it my eyebrows? Is it my eyebrows again? Right, Jonathan, this isn't designed to have a lug on it, is it? Because that's what it's for. This is just a clamp, yeah? I'll just strip off a load of cable and compress it in this bolt, yeah? Okay, cool. So I was going to say, I just wanted to be sure because I'm a virgin, aren't I? This is my first time. All right, cool. I'll do that then, bruv. All right. Right, boy. There we go. There we go. I'm going to curl that up a little bit. And then I'm going to get my cutters. I'm not that impressed, to be honest, with that, but like, I mean, it's going to be sound by the time I'm done with it, that's for sure. But I just prefer I prefer a crimp. I prefer a lug. I even got heat shrink and everything because I thought that's what it would be, but it's not. So yeah, I'll just fold you lot over. That rain, it keeps wanting to go, doesn't it? But calms down. Okay. Well then. There's only one fair way to do this. Just clean the blade because this has actually been in the hole with us. There we go. I'll take the dirty bit. That was the only way to resolve that, you see, fairly. Right, what are we saying, 13 mil? Yes, sir. This is a proper ghetto connection for the UK, but to be honest, this would be more than satisfactory anywhere else. Obviously it's not as nice as lugging it, I suppose. Yeah, that'll do. Now, we can test it. So, shall we? We don't actually need anything bar the test kit now, do we? No. Let's get the tools packed away. Let's just get tested and get out of here. Right, so, let's get this balance right, otherwise this is going to end up in the ditch with me. We don't want that. This tester does do earth electrode testing, like the free prong test or the free probe test, but I haven't got a kit with me. I am going to speak to Q-Tech and see if I can get one out, and I'll come back to this job actually because it's pretty chill here and show you the full process of that on site. But I have actually done a video of that with Paul Meenan as well, which I'll link below, where we go through the full process. It was back when I still had the GoPro, so if you like the sort of visuals that you're used to these days. Yeah, sorry, but we are just going to be doing a ZE test, basically an external earth fault loop impedance test using this tester, and that's how we're going to verify it. Now let's speak about the regs briefly. So it wants to be below 200 ohms on a good day. Good rule of thumb is on a wet day you want it below 100. I think the NIC say around 21 ohms. I'm looking for anything below 100, to be honest. I'll be happy with. I say anything below 100. It's still quite dry. It's spat, you know, periodically throughout today, but it's not wet. I have just poured a load of Monster down here. That was probably what did it, not the Kango, it's the Monster. But yeah, that's what you're sort of looking for with earth electrodes. It's under 200 on a dry day, under 100 on a wet day, and around 21. Obviously, if you have an upfront RCD, a time delayed one, that completely changes it. That will dictate your value. I think the highest you can go up to is like 1667, but yeah, we're looking for under 200, ideally under 100, and ideally under 21. But let's talk about this setup quickly. So this is our earth rod. You can see it here. Comes through the ground past this lovely torpedo, through this duct, up here, round into our board. Then we've got our mains, which come from this head, through the meter, through this isolator, into our main switch. And then we've got two circuits, socket circuit 1, socket circuit 2. Now, ideally, you would have an upfront RCD for TT systems because that provides fault protection. That is because you're relying on, you know, an earth electrode at a higher impedance that could fluctuate and destabilize and stuff like that. So yeah, you want that RCD for fault protection. We don't need it because what we've done is we've got a gland at the point of entry to the DB, and we've also got cage terminals at the top. So that basically the fault is that these cables could come out and obviously be live and touch the casing or whatever. You can negate the need for an upfront RCD by having fixed glands and fixed cages around the cables when they're within the board, so that can mitigate the need for the upfront one if there's not any other reason for it. In the last video I was given RCD sockets and MCBs, but of course, although these sockets are ran surface, they need the fault protection due to the TT installation, so we had to swap these out for RCBOs and swap these out for normal sockets. It was just a mix up with materials basically. So what I'm going to do now is liven this up. I'm going to get my leads out actually, but that's good that that's live anyway. Get my leads out. I'm going to go with you, and I'm going to go with you. And then I'll round that up. Round. Earth. Get these on, get that on. And then ZE, we want this disconnected. Not that there's going to be any parallel paths or anything. We'll still disconnect it and get true ZE. I want to go onto loop high, live and earth, 0.1 resolution. Let's go on here. We are live. And that is not great. Why is that? 16 ohms. I mean, that's brilliant. That is lovely and low. 16 ohms there. What you can do with the Q-Tech is you can change the resolution, so you can go between 2 and 3 decimal points. Where I had it on 3 decimal points, it didn't like it. It just said greater than. Just had to change that to the 2 decimal points. Press that button, and again 16.61 ohms. So it's below 200, it's below 100, and it's below 21. So that is banging. I'm very, very happy with that. I think the monster's probably helping a little bit. Let's turn that off. Let's get that put back into the installation. There we go. Let's go get my torque driver, get all this torqued up. We'll run through a few quick tests on the socket circuits as well. Check that the RCDs work, and then that'll be this one all buttoned up. So first up, main switch, 2.5 Newton meters. Tut, Mike, I left this tight. What they say is you should untighten your torque screwdriver, because it's basically, what am I doing? It's basically a spring, that's what it works on. If you leave the spring coiled up, the spring's going to lose strength, I guess. That's what they're saying anyway, but yeah. Okay, so they're tight. RCDs should be 2.5. There we go. Cool. Neutral bars are the same. There we go, and then we've got SPD wants to be 2 Newton meters as well. 2, 3. RCBOs want to be 2 Newton meters on the incoming. Got to do the bottom of the main switch. Let's bump this back up to 2.5. Main switch. There we go. And then RCBOs, we just want to change over to the smaller modular 1 tip. Bosh that in, and they want to be 1.2 Newton meters. So this is where this torque driver really shines actually, because it goes between 0.8 and 5 Newton meters. And that's quite a decent range. You'll find a lot of them are either between 0.8 and 3, and then or 0.8 and 2, and then 2 and 5. And yeah, I know Weiro, you have to get 2 screwdrivers to do what this one does. I don't know how they do that, but yeah, it's the most versatile torque screwdriver, I would say. There we go. Right, so we're all torqued up. Right, so notes. New note, ZE was 16.61 ohms. I'm going to do the same test with all of the parallel paths in place. And then I want PFC is 15 amps. Jesus. We need to change our leads over to my socket lead. Suck it, man. Bush, bush, bush. Let's go loop high. That's going to trip the RCD, you idiot. Let's go loop low. Main switch must be on. There we go. Okay. 17.63 ZS RCD. Let's do auto. Test the hell out of this while we're here. 38.6, 38.6 without seconds. Let's go to this one, which is not the first one on that circuit. The last underline, sorry, that one is. Let's go loop high. Not sure how I feel about that, to be honest. I just don't see that being 0.9. 17.68. 2RCD. So if you bring that in, just ignore Woody. Hopefully you can see the screen. But yeah, this is one of the things I love about the Q-Tech, is when you do RCD tests, it displays all of the results on the screen. It's a really intuitive display. It's probably one of the best displays, to be honest. Exactly the same as the last one, to be fair. Yeah, 38.7. But yeah, you can see there, you get all the results on the screen. It's really easy to read. What I need to do is write that down. So 38.7, 38.7. I just need to do a quick R1, R2 basically. Drop down to you. Get you out. You in there. .41. So you might have seen there as well on the tester screen that was dancing about a bit. Then I flicked this switch on and off, and then it stopped, the reading stopped fluctuating. And what that is basically a sticky contact in the switch. So when you're testing sockets or any accessories, isolators or anything like that, where you're relying on a switched contact on a mechanical joint, just operate it a couple of times if it's jumping about, and it should cure it. So 0.41 on that one, R1, R2, 0.41. Right, I am all tested up. I'm happy with it at 16 ohms, to be honest. That's a great effort. And yeah, it went in pretty well, to be honest, until we hit whatever we hit, and then the Kango done it. So that all went very well. It is 3:30. I'm in my hometown, so I'm going to be home for 4, which is banging. There's a bit going on over there. I'm going to get the cover on this fuse board, get it all labelled up. Obviously, yeah, probably fit some banding around these, tails, I think. I'm not sure how I feel about it, to be honest. I'm going to tie up the earth to it. I've got to contact the DNO or contact the office who are going to contact, I think it's actually not DNO, I think it's the energy company. And they're going to come out at some point when convenient and reseal it all up and check it over. But yeah, that's all for this one. Hopefully, just realised I need to talk that up as well. But yeah, hopefully you've enjoyed the video and the last one as well. I know they were sort of joined, but I did want to split them up so that the videos aren't too long, and I could also have different subject matters in each video. But yeah, it's been a cool little job. I think we're actually gonna get, I say we, Burgess Electrical, who I'm working for today, are going to get, well they've got to rewire this place. So there's 2 houses out the back there and there's flats going here. So maybe I can come back and show you it all. Like, yeah, there'll obviously be like a rye field or redheads anyway. There'll be some sort of main setup, and that'll be on the TT as well, so that'll be interesting. Hopefully the pit will be in. I'm going to stop waffling anyway, leave you guys to it. Thanks for watching again. Check out Loadout, all of the tools and equipment used in the video. Link for that will be below. Massively supports me and the channel. Make sure you subscribe if you like this sort of content, and I'll catch you guys in the next one.